In this lesson, we're going to take a look at the concepts called the mole and Avogadro's constant. So when I buy eggs, I usually look for a dozen eggs. And when I talk about a dozen, I mean 12 of something. If I'm buying mittens or socks, I'm looking for a pair of mittens or socks. And we all know that that word represents the number 2. So we already have different words that represent numbers, and we have the same thing that's going to happen in chemistry. So the difference is when I am buying mittens, I have 2 hands that I need mittens for, and so that is going to come in a pair, one for each hand. When I'm talking about the number of atoms of a substance or the number of molecules of a substance, an atom is so tiny that I'm going to need a lot of atoms or molecules. And so a mole represents that many items, and so I'm going to use that for atoms or molecules. So this is a really big number that I don't want to write. So I want to write this as 6.02, but I definitely have way more than 6 here. So every time I multiply by 10, that's going to shift my decimal place over 1. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 would get me to over there, which would make that a whole number. So I'm multiplying by 10 23 times. So 6.02 times 10 to the 23 is equal to this large number. And when I'm talking about 1 mole of something, I mean this many of it. So that number, the 6.02 times 10 to the 23, that is something that we call Avogadro's number or Avogadro's constant. And so 1 mole of anything has 6.02 times 10 to the 23 of those. So if I have 1 mole of water, then I have 6.02 times 10 to the 23 molecules of water. If I have 1 mole of sodium, then I have 6.02 times 10 to the 23 atoms of sodium. So if I want to find out how many atoms are in 2 moles of sodium, so 1 mole of sodium would have 6.02 times 10 to the 23 atoms of sodium. And if I have 2, I need to double that amount. So each mole has 6.02 times 10 to the 23 atoms of sodium. So in total, 2 moles of sodium means that I have 1.20 times 10 to the 24 atoms of sodium. How many moles are 1.2 times 10 to the 24 atoms of carbon? So here I'm working in the reverse direction. So I know how many atoms I have, but that's a very large number and it doesn't make sense. And this is one of the reasons we use the term mole. So how many moles is that? So I want to figure out how many units of 6.02 times 10 to the 23, or how many moles are in there. So for example, just to make this a bit more concrete, if I had 18 eggs and I wanted to figure out how many dozen I had, I would divide that by how many are in 1 dozen, which is 12, and that would tell me that 18 eggs is 1.5 dozen. So similarly, I'm going to take my number of atoms and divide by how many atoms would be in 1 mole, and that is going to tell me how many moles of carbon I have. And when I divide those 2 numbers, I end up with 2. So I have 2 moles of carbon atoms in 1.2 times 10 to the 24 atoms of carbon. How many moles are 1.81 times 10 to the 24 atoms of sodium? So same thing, I'm going to divide by how many atoms would be in 1 mole, and that gives me 3.01 moles of sodium in 1.81 times 10 to the 24 atoms of sodium. So in summary, to calculate my number of moles, I would take, the number of particles I have, so that could be atoms or molecules, depending on what I'm talking about. I take the number of moles, multiply by 6.02 times 10 to the 23. And to calculate moles, I take how many particles I have, so either how many molecules or how many atoms, and divide by 6.02 times 10 to the 23.